Hey, welcome to Physics 2 Lab. This one is about series and parallel. So a little for the introduction. Resistors are marked by these squiggly lines in a circuit, whereas the straight line would be considered wires in a circuit. You'll also have a battery that is attached to these wires with some voltage feed, a supply battery. When in series, resistor 1 and resistor 2 will have this look where it must pass through one of the resistors to get to the other resistor. Okay, they're in order, they're in series. It must pass through the one to get to the other. That's how you know it's a series. These resistances, when it's series like this, can just be added together. Resistor 1 plus resistor 2 will give you a new resistance of the series. And this entire circuit can be replaced by just one new resistor RS. Okay? It's combining the two resistances. Also, when in series, the current that flows through the resistors is the same in resistor 1 as it is in resistor 2. So the current from resistor 1 and the current on resistor 2 is the same. You can think of this as like traffic flowing through a set of stoplights is the best way I can describe analogy-wise. Is that if one of these lights is red, that the cars, no matter what, will have to stop behind that light. Okay, it doesn't matter if it's this light or this light. If one of them is red, that's the one that's impeding the traffic, and the traffic will only flow as fast as the slowest one allows. Okay. So the current through both of these will end up being the same. Now we know in Ohm's law, V is equal to IR. As long as we have 2, here we have R and we have I, then we can solve for the voltage. Okay. This is the way that series works. On parallel, if we wanted to do the same thing, and I have 2 resistors that I want to combine into one resistor, parallel. Parallels are a little bit different. As you can see here on the series one, you have to flow through the one to get to the other. On this one, it Ys, and the current, the charge can actually go through either or separately. Okay? So that's the difference on this. And what we do is, whereas here you had just the addition, put everything in the denominator of a fraction. And they have to be added like this. 1 over Rp is equal to 1 over R1 plus 1 over R2. Okay? They're reciprocals. Now on this one, as the current charges come in, current can flow through. Current's going to pick the best path, the easiest path for it to flow the most. So the current on this will not be the same because it has a choice on which one to go through. Okay? But what will be the same is the voltages. For instance, if we have 12 volts up top and 0 volts down below, 12 volts is going to be at the top of each of these resistors, and the bottom of the resistors are going to be 0 volts. Okay, so it's easy to remember that the voltages must be the same. So here we will have R and we will have V, and we can solve for I. Now finding the equivalent resistance is what we're going to be doing here in the lab. We'll also be dealing with finding currents and voltages through resistors set up in series and in parallel. All right, so let's head to the bench and do that. Okay, here we are at series and parallel circuits. We're on step 1. Here we have our board set up, much like we had it for Ohm's law. The power supply here is supplying power through a current sensor. The current sensor here is then plugged into the positive side of the board. The negative of the power supply is plugged into the ground. We have a yellow jumper wire from the positive terminal of the board to the 10 ohm resistor. The 10 ohm resistor has a voltmeter on it for us to monitor through Logger Pro. And then the ground wire connects to the ground post on the board and completes the circuit. Now that is labeled as a 10 ohm resistor, but we are going to double check to make sure that it is. We are going to use Logger Pro for that. I will go ahead and hit collect, just as we did for Ohm's law. And I'll vary that voltage up to about 3 volts. That's pretty good. Okay, using that then, we're going to do a curve fit of just a linear line, just like we did in Ohm's law. And we'll see here that our slope, 9.94, is right around the 10 ohms that we expected for our resistance. Okay, we're going to record that in your Excel. You'll be given that. And then we'll compare the resistances for the color code and the measured value, just as you did in Ohm's law. And then we'll step on to section 2. All right, section 2 of series and parallel. We have changed from the 10 ohm to the 51 ohm resistor, and we're going to measure that one with the Logger Pro as well. Okay. So we'll just come on over here. I'm going to do the same scenario. I'll hit collect, and I will slowly raise this current and voltage, probably up to about 3 volts. So what you want is a nice straight line. Okay, should be enough. And sure enough there, our slope, 51.06 with some uncertainty. That'll be recorded in your Excel for you to use. The section 2.5 says, which resistances do you wish to use? We're always going to use the computed ones. They're much more accurate than the color-coded resistors, since they have a high tolerance on the color-coded. So we'll be using these measurements for the rest of the lab. Okay, series and parallel, this is section 3. We have taken our 2 resistors, the 10 ohm and the 51 ohm. You can see here we have connected them in series. The power comes in through the left yellow jumper through the 10 ohm, which is where the red cable is connected to our voltmeter. The second yellow cable connects the 2 resistors, jumps the 2 resistors, where it passes through the 51 ohm resistor. And the black lead is our negative on our voltmeter. And then the green connection just brings it back to ground. Okay, so we will take and test this with Logger Pro. Remember, these are in series, so they should add together. We'll give this a shot. I'm trying to raise the voltage as slowly as possible to give us a nice linear fit on our graph. Okay, so here we have our linear fit. We are looking at 62.16 plus or minus the 0.114. Okay, so that value will be recorded in your Excel, and we'll use that to determine the rest of 3, where we will calculate the expected value of what we expect to get for this. Okay, and then section 3.8, we'll compare those 2 resistances, see if they agree. And then we'll go on to section 4. Okay, section 4 of series and parallel. What we're going to do here now is just using Logger Pro as the voltmeter. I'm going to take a measurement of what the supply voltage is outputting, and then I'm going to also take a measurement of each of the resistors on their own, how much voltage is being passed through. Now, when we look at series and we solved for V, you should see that the voltages should add together to become the supply voltage. These values here will be in your Excel, so look to there for those values. Okay, so next for section 5, series and parallel, we're going to do just like we did for the voltmeter, but we will be using a second current sensor, and we will be determining the current that is traveling through the 10 ohm and the 51 ohm separately. For these to be true for a series, the current should be the same passing through each of the resistors. This again is done all through Logger Pro, and this data will be in your Excel. All right, here we are, section 6, series and parallel. We have now wired them up so that the 10 and the 51 are in parallel with each other. Okay. So we have power coming into the 10, and then a jumper connecting the 10 to the 51 on this end. We have our voltmeter hooked up to the 51. Again, we have another jumper connecting the 2 on the other side between the 10 and the 51, and then the ground wire leading back off. So these are set up in parallel. Okay, we're going to go to Logger Pro, and we're going to do the experiment again, trying to measure the combined resistance. That's good. Let's do a linear fit on that line. Get our parameters in the right order here. And see there we get a slope of 8.382 with some uncertainty. That value will be recorded in your Excel, and then you'll have to compute what you would think the expected total resistance should be for 6.6. Right. For sections 7 and 8 of series and parallel here, what we're going to do is take and use the voltmeter through Logger Pro, and we'll measure the voltage across each of the resistors. Remember, these are now in parallel. And then we will do the same with our current sensor. We will measure the current through each of the resistors. Okay, those will be sections 7 and 8 in your Excels.